So this little section of chapter 5 kind of doesn't seem to belong here, but here it is. So formula mass. So we just learned about formulas of compounds and how to write them from the name and how to write names from the formulas. And now we're going to turn to the idea of mass. And so for any compound, what we call the formula mass is the sum of the atomic masses of all the atoms in its chemical formula. So you take the number of atoms of the first element times the atomic mass. How do we know what the atomic mass of an element is? Where do we find that information? On the periodic table. That's the number under the symbol in the periodic table, is the atomic mass in atomic mass units. And then we would multiply the second element's mass by the number of atoms. And so just like, let's make up an example here. If I had a box that had 2 8-pound bowling balls, oops, too many L's, and 10 10-pound balls, box of bowling balls. Why? I don't know. How would we find the mass of the box? Yeah, we're going to look at the mass of the balls inside. So there's 2 8-pound balls, right? So we would take 2 times 8 pounds, and then we would add 10 times 10 pounds, right? So this would be 16, and this would be 100, and we'd say, oh, well, the box must weigh about 116 pounds. It's the same idea, finding the formula mass of a compound. We look at the formula, it tells us how many atoms of each element are in a formula unit. We multiply those numbers by the mass of each atom, and we add them up. Same as finding the mass of a box of bowling balls. So let's calculate the formula mass of dinitrogen monoxide, N2O. So how many nitrogen atoms are there? There's 2 nitrogen atoms, and how much does each nitrogen atom weigh? Look on the periodic table, and under nitrogen says 14.01. So that's atomic mass units. And how many oxygen atoms are there? Just 1. And how much does that weigh? 16. So we put those together. I should be able to do that in my head, but my head's not working. And I left all of my calculators at home. That's just fabulous. 2 times 14.01 plus 16, 42.02. So 1 molecule of N2O would weigh 42.02 atomic mass units. Any questions? Now, if you look at different periodic tables, you'll notice that they have the atomic masses listed a little bit differently. Okay, the periodic table I gave you for the exam has 4 significant figures for the molar masses, or the formula mass, the atomic masses. Too many terms. Other tables will list more. So what I'm going to do in my lectures is I'm going to use the numbers from the periodic table that I give you on exams. I have a lot of them memorized, and it's just a lot easier. We should consider significant figures when we're calculating formula masses. If we think about adding these up, this is going to have 2 decimal places and 2 decimal places. Generally, we will end up with 2 decimal places in our molar masses. Yeah, so that's the end of chapter 5. Little snippet at the end. most of this chapter was about formulas and names of compounds.